Good morning, BYW students. Mr. O'Sullivan. We're starting a new unit today. Based off your noticings and questions last week, yes, we are going to be doing a little quick mini unit on circles. So before we go into circles and do some of the algebra, our definitions. So I'm just going to read through the definitions real quick. A circle is the set of all points in a plane that are equidistant from a fixed point of the plane called the center of the circle. That's its geometric definition. And giving you a heads up, circles are named by their center. So for instance, if my center is O, it would be circle O. If it's Q, it's circle Q. Okay? The radius is the line segment from the center to any point on the circle. And another thing we need to know is that its plural is radii. So if you hear me say radii, I'm just basically saying multiple radiuses. The diameter is a segment with both endpoints on the circle, and it goes through the center. Your interior and exterior points, that's pretty self-explanatory. Interior is the points inside the circle, exterior the points outside the circle. The arc of a circle is sort of like its side length. It's a curved portion of the circle, and its measure must be between 0 degrees and 360 degrees. So for instance, if I look at this visual right here, what I have right now is arc AB. So I can say arc AB like this, and that's how you say arc AB. You basically draw half a circle above it, don't connect it, and you put it above it. Arc AB is the exact same thing as arc BA though, so they're congruent. They're the exact same thing, and that's just one of the multiple examples of an arc in this picture, or that circle. A semicircle is an arc that represents half the circle, and it measures 180 degrees. And just giving you a heads up, that's basically just half a circle that's connected to a diameter. Good, let's go on to some more visuals. A minor arc is an arc whose measure is less than 180 degrees. So for instance, in my visual to the left, AC is a minor arc. Minor arc AC. A major arc is an arc that is greater than a semicircle and measures between 180 degrees and 360 degrees. It's usually named by 3 points. So for instance, in this visual, I can say my major arc is AXC. Major arc AXC. Your central angle is an angle whose vertex is the center of the circle and whose sides are the radii. So for instance, in this visual, angle AOC is your central angle because it goes through the center. Degree measure of an arc is equal to the measure of the central angle that intercepts the arc. The degree measure of an arc is never the measure of the length of an arc. So it's not like, 5 centimeters. It's basically saying that your central angle is equal to your arc measure. So since this is 75, this is 75 degrees. This is also 75 degrees. They're all 75 degrees. Congruent circles are simply circles with congruent radii. Congruent arcs are arcs of the same circle are congruent. Concentric circles are circles that share the same center. It's sort of like a bullseye. And then the other two theorems are pretty self-explanatory. Let's go into some math. Problems that are associated with them, we need to know. So what we're going to do right now is apply the definitions that we looked at on the front to analyze this. Okay? So in our visual, we have circle O, AC, and BE are diameters. The measure of angle DOC is 40 degrees, and the measure of arc AE is 80 degrees. We want to find all those missing values. So the first thing we want to find is the measure of arc ED. So here's the thing. I know AC is a diameter based off the description in the question. So when I have a diameter, it's going to make 180 degrees. So I know this plus this plus this should be equal to 180. So 80 plus 40 is 120. 180 minus 120 is 60. So what I know is that the measure of arc ED is 60 degrees. The next thing I want to find is the measure of angle EOD. So I go to my image. I'm going to use blue this time. I start at E, go to O, and I end at D. This is a central angle, so I know it's equal to the arc it intercepts. So it's equal to 60 degrees. For C, I want to find the measure of angle BOC. So we know in our question that BE is a diameter. So if BE is a diameter, I know that everything to the right of it has to add up to 180. So right now, also just giving you a heads up, arc CD is 40 degrees because the central angle is 40. So 60 plus 40 is 100. 180 minus 100 is 80. So I now know that the measure of arc BC is 80, which means that the measure of angle BOC is 80 degrees as well. I now want to find the measure of angle AOB. We're also going to write down that the measure of angle AOE is 80 degrees as well, because of central angles intercepting that arc of 80 degrees. So I want to find the measure of angle AOB. Well, I know there's 360 degrees in a circle, and I have 80, 60, 40, and 80. So I'm just going to do 360 minus that sum. So if I do 80 plus 60 plus 40 plus 80 in my calculator, I'm going to get 260. I'm then going to subtract that from 360, and I'm going to get 100 degrees. So that means angle AOB is 100 degrees. I now want to find the measure of arc AB. Well, the measure of arc AB intercepts this angle. So I know that it's 100 degrees. Now I want to find the measure of arc BAD, or arc bad. I'm going to do a little erasing of my middle stuff. I want to find the measure of arc BAD. So I simply do this. Start at B, go to A, and then I end at D. So I'm simply doing 100 plus 80 plus 60. I type that into my calculator, or you can even do it in your head, and I get 240 degrees. I now want to find the measure of arc dBe, which means I start at D, go to B, go to A, and end at E. So I'm doing 40 plus 80 plus 100 plus 80. Doing 40 plus 80 plus 100 plus 80, which is equal to 300 degrees. Now I want to name some minor arcs. That means we have to go back to our definition of a minor arc. A minor arc is an arc whose measure is less than 180 degrees. So some examples of some minor arcs in this visual are arc CD, arc BC, and arc ED. And the reason why those are measures of our minor arcs are because, for instance, arc CD is only 40 degrees. Arc BC is only 80 degrees. Arc ED is only 60 degrees. You can find multiple examples as long as they're less than 180 degrees. A major arc is between 180 and 360 degrees, and we typically name them with 3 letters. So some examples of some major arcs are BAD and DBE. And then a semicircle is equal to 180 degrees, so we just have to make 180 degrees. So 2 examples are BDE and arc CDA. And that's it for today. Make sure you write down some of these definitions, make sure you've memorized them, because it does change the type of problem you're dealing with. If you have any questions, email myself or email Miss Kimmick. Don't forget to do your daily question and noticing, and make sure you work on your independent practice. Have a great day.